Hello, everybody. Just getting started here. Let me know if you can hear me. It's been a while since I've live streamed, so my setup was all but a big mess. And apparently, I have completely forgotten how to do this. Something is up today, right? I don't know what is up. Everything seems fine on my end. There are zero dropped frames. CPU is just 5%. 30 FPS is going really nice. Something feels up though. I want to make sure that this is a good one. Hey, Zed, I see you on Twitter. X. Nobody on YouTube. If you're watching me on YouTube, can you please comment? I can see people on Twitch. Uh, no comments on Facebook so far. Zed, can you please confirm I'm live everywhere? And then when we can get started, probably. Watch your own VOD in Twitch by going to your profile. Yeah, probably I can do that. Uh, but I wonder if it will have some form of echo or something. Let me see if I can mute myself here. Oh, I think this is a neat trick. I Yep, FPS are is a little bit odd, but I think it'll do. Uh, Let me switch to the other one. Probably going to. How do I see this? Yeah, maybe I will take it out. Come on. What is happening? Oh, there you go. Can you guys hear me? Yep, I'm not muted, right? Hey, Hamza on Meta, Facebook. Hey, Usman. Hey, Mehdi. Mahdi. I think I'm pronouncing your name correct, right? Zed, I see you on YouTube, on X. Things are starting to. Uh, People are starting to show up. Things are looking good, probably. I'm making my dream project with Go plan on command code. Mehdi, thanks a lot. Okay, we are going to be discussing a lot of things today. Pretty excited. A lot has happened since the last time I live streamed, right? So it's gonna be a lot of fun. Hopefully, uh, I don't know if you saw, but like, Bolts, can you confirm it's all good on Twitch? Zed, you can confirm on YouTube, and then I can just get started on this. I am sure I am recording this, but I'll just confirm very quickly. I have like a bajillion windows open. Yep, I am recording it. And okay, there you go. I'm probably gonna close Twitch for now and gonna get started here. Okay, we are going to be discussing a lot of amazing things today. I've been traveling a lot in since I've started live streaming just quite recently. I think we did like 4 live streams in April every week. That was really good, and I was really like bummed out when I couldn't do one in May. But in May, I started traveling. There were a lot of conferences. A bunch of them in New York, in San Francisco, Mountain View, Google I/O, and the typical odd event of Quad. The vibe there was really weird. Ended up having a lot of chat with Sam Altman and at OpenAI's HQ. So it's been a busy month. In command code kind of grew a lot, right? Uh, I can't even begin to explain what my life is like right now. I'm like spending 20 plus hours uh, every day, and it's just been crazy. I have like so much happening. We just hit 10,000 customers on command code in 30 days, by the way. Thanks a lot. I think a bunch of you are actually here. Um, which reminds me, I probably should go and share in Discord that I am live. I kind of always forget to do that. Oh, there you go. Everyone, maybe everyone, I'm live discussing open models in repair harness. Tube, X, Twitch. Links here. EDF and then live. I think this should be it. Yep. Okay. Um, yeah, a lot happened in 30 days. I think a lot of new people are joining the stream as well today. So, welcome everybody. I'm going to share a little bit about what we are up to. Um, this thing that I do, I hope to do it every week. I hope to live stream every week. Okay, now Discord is sending me a bunch of audio notifications. I think I gotta turn that off. Give me just a minute. You can all have a lot of fun here watching me do all of this live. Where are notifications? Audio notifications. Where are they? Preview new sound. Please do not play any sound. Yes, no sound. Yeah, I think that should cover it. Probably. Yep. Okay. So, what I do in these live streams is I generally just try to do it every week. I go live. We have a bunch of discussion. You all can share, what you want me to talk about, and I also come with an agenda. Like I have a bunch of things that I discuss, and on the live stream, this live stream show, like what I do is um, I record a bunch of videos while you all are watching, and those videos are then posted on my X and on my YouTube and everywhere, right? So, yeah, I see a lot of people are joining. Hey, part from X. Thank you, Ritesh, on the 1 million run rate of command code. It's been crazy. It's been crazy, right? Um, Bolts, thanks a lot. The merch came out to be looking really, really nice. Um, and we are hoping to start sending this to our customers. So if you're using command code, you can probably expect to get like this cap or this hat or a t-shirt or something. We're figuring out the logistics. Apparently it's very hard to figure out anything if you have like 10,000 plus customers, and I don't want things to go crazy. And the team is actually busy shipping a lot, unbelievable amount of ships are happening. I think since morning we have shipped like maybe 3 or 4 releases already, right? So we'll be probably doing this swag drop soon. And today I'm thinking that we will discuss a little bit about what is going on with command code. What is this? How are we able to, outperform how were we able to get DeepSeek to outperform Opus 4.7? What is this repair harness thing that I keep talking about? And a bunch of other things. Like apparently, like I'm now a creator. Twitter has this reaction with video thing, and yesterday, after like 2 months, I went outside to touch grass, did a little bit of running, and I came back, recorded this video. I was sweating at the time, so I didn't expect much. It was like, I don't know, like 9 p.m. or something, and yeah, I think it resonated a lot with developers. So pretty happy to see that. Yeah. Bolts, by the way, I saw like you applied, and I think you got into the your assignment. Will we probably Sake will probably be getting on with an interview pretty soon with you. So yeah, we are hiring across the board. If you go to my Twitter profile, X profile, you can pick the right role for if mostly we are hiring full stack developers, but yeah, pick the right role, and hopefully we can have a chat, and we can grow the team, hire some of the our users. That would be amazing, right? 1 billion tokens shirt, 100 million tokens cap. Oh my god, I would probably do it something like the opposite, or maybe we should do like a 10 billion token swag, complete swag thing or whatnot. It's a good idea. I won't lie. Would love to talk to you about CMD9, uh, next project, setting up stack, what you would be teaching, which LLM you would prefer, various use cases. Awesome. Also, we were running like a giveaway. Uh, we need to probably announce a bunch of winners. You just need to sort through that randomizer to go do that. And by the way, right now, I don't know if you guys missed it. Quen 3.7 Plus right now is still free on command code. Sorry, give me a minute. Hey Ritesh, from YouTube, and just gonna quickly see if there are new comments on Facebook before we get started. Hamza Malik is saying there is no provide support. I don't get you, bro. Feel free to send us an email at support@commandcode.ai. We support a bunch of models now, so that should be it. Hey Usman from Korea, nice to see you here. Okay, I think I'm gonna get started. I am not giving you any pointers. Bolts. I've been working with an open harness that's designed primarily for OS models. It's private right now. Maybe someone, Night Folk, probably, right? If you all are using command code, if you can probably share like what was one of the few things you really enjoyed about command code, like if you can share a little bit about that. What has your experience been so far? Uh, Waiting for comments to come in. That would be, I think, something interesting that we can probably chat a little bit about. Yep, but the giveaway winners should be getting announced soon. I think Mada is in the other room. She will be taking care of it. I know we are behind on it, but I did cross 50K, which was the deal. When I cross 50K, I'll announce the winners, right? So I think let's get started on everything that happened this last month. Like I don't think I can actually go and I've been go down and like review everything, but this is what happened. Like at the end of April, I was looking at DeepSeek had just launched V4 Pro and Flash models, and remember back in 2023, DeepSeek became a big deal, right? There was OpenAI, GPT was all the rage, and all of a sudden DeepSeek came around and started this open model thing, which was actually really really nice to see. You know how big an impact open models can have. And then I think it launched a bunch of different research on different things like caching or their file system research and a bunch of other things. But mostly they have been quiet, right? They launched a couple of models. They were, I would say, they were not that great. There was, I think, R1 and a couple others. But V4 models, the family of DeepSeek V4 is amazing, right? So um, I think a lot of people on X start sharing that, oh, I can't really use it so well, right? So I ended up looking at that a lot, right? And that is what I'm going to be probably talking about here, right? What Let's actually get started. DeepSeek V4 uh, Pro and Flash, right? Why are they such a big deal? Lots happened this month. Mm-mm-mm. Ritesh is saying the actual way that DeepSeek responds is completely different in command code. I've seen difference. I have user. Yep, this is what I'm gonna talk about, right? So I think Zed, I'm gonna start the video part right now. You can take in the marker, right? So I think I can stop and start another recording probably. Give me, guys, give me a minute. Yep. Uh, okay, I've started another video. Awesome. Thanks for confirming that. Okay, let's get started on what happened with DeepSeek this month, right? So, where should we begin? I think we should start here. I'm gonna start recording the videos, guys. So if you have comments, feel free to keep sharing. I am gonna, you know, keep coming back to your comments here and there, right? Okay. How do we start this thing? I think maybe I need one more uh, link open. So a couple of good things happened, right? Like we crossed 1 million in ARR, right? I think I shared that with a video as well, or with the image as well. Maybe it's here somewhere. Where is it? Oh my God, we we have been sharing a lot of things. Okay, I think I found it somewhere here. Yeah, I think we can have this one here. Uh, this one here. So we did this. This happened in. Then this happened. And I think I can have like probably one more thing. Sorry for the whistling. And finally, yep, pretty much, pretty much. Yeah, there you go. Okay, let's get started. And what was the day when I posted? Literally 1 month ago. Exactly 1 month ago, I posted this tweet claiming that I have been able to fix DeepSeek in a way that now, in our internal benchmarks, DeepSeek outperforms Opus 4.7. And it started something crazy in the community. I kind of don't like this starting. Okay, let me. Okay, retake here. Exactly 1 month ago, I went viral on Twitter. My post is an engineering deep dive on how we made DeepSeek outperform Opus 4.7. And that is what we are going to discuss today. Just about a month ago, DeepSeek went ahead and launched their V4 family, DeepSeek V4 Pro and DeepSeek V4 Flash. And I started looking at that in a very different way. There were two groups of people on Twitter, and they were mostly split across something like this. There was a group that was claiming that, oh my god, this DeepSeek V4 Pro family of model is really good. They were pro DeepSeek, and then there were like naysayers, right? And there were just a lot of people that I respect in the community, amazing developers who were claiming that it's performing really, really well. Um, it's super fast, and the intelligence level that DeepSeek V4 has is somewhat of a match of that of Sonnet or Opus 4.7, right? But at the same time, there were like a lot of people who were like, no, I tried, uh, it doesn't work. It just is super slow, fails a lot, and tool calling is a mess. So I decided, how about I give it a go and try it out and see for myself, right? At that time, DeepSeek V4 was not shipped in command code. We took like about a day, maybe, or maybe we shipped it at the same day. And I started exploring early on, and this is what my experience was, right? So let me actually make it a little bit bigger. There were like pro in there, were like naysayers. I'm gonna probably retake all of this. Completely out of practice of doing this after a month of break. Can you imagine that? The general sentiment when DeepSeek V4 Pro and Flash were launched, and when DeepSeek V4 Pro and Flash were launched, the general sentiment in the community was kind of like a not really an even split. There were a lot of people that I respect a lot who were saying this is a really intelligent model. I think I'm writing. What is going on? Everything's breaking. So a lot of people that I respect in the community, they were saying things like, "This is a really intelligent model. The cognition level it has is amazing. It's probably like Opus tier uh, model, and it is fast and it is quite stable." But at the same time, there were like probably 80% of the community, which I think were probably saying things like, "It is super slow. Tool calls do not work," right? And this is the thing that I kind of want to focus on, right? Like, why were a lot of people saying that tool calls are not working? Like, what was what was so different for them in these guys, right? So I started looking at it, and we had shipped a DeepSeek V4 probably the same day or the next when it dropped in the community, and I had like a bunch of data on error stack in command code, and I saw something completely crazy. I saw that DeepSeek, being an open model, has a lot of tool calling issues, and I started looking into that. And I remember like it was Friday, and my team was actually going off, and they were thinking like, yeah, it's how open models are. But I was still looking into it, and I was like figuring out like maybe there is a fix here, right? I'm not gonna fine tune DeepSeek. I'm not gonna fix the pre-training, but maybe there is something I can do in the harness that can improve the performance and reliability and stability of the tool calls across the board. And I ended up discovering something that we have now been calling repairs, tool repairs. And we have this huge tool repair harness in command code that outperforms most every other coding agent harness in the market, especially for open models. And this is the reason why, right? So let's actually just go through this post so I can share what I discovered, right? So I've been thinking a lot about why are open models bad at tool calling, right? And I'm almost sure like it's always a harness problem and not a model problem. Models are gonna hallucinate. They're gonna go make mistakes, and that's why the harness should be able to figure things out for it. Sometimes deterministically, sometimes non-deterministically, right? This, however, is a deterministic fix, right? So the thing is, um, we are building command code, and I ended up looking at the tool input repair layer that we are building. This is like a review of that, right? And what I saw was that DeepSeek V4 Flash was consistently failing on our slash review skill that comes bundled with command code. In every shell command, the read file call was bouncing back, and there were like on average 56 failures per tool call for shell, for read file, for slash review, for DeepSeek V4 Flash. And I was like, this seems like a big pattern. The model should not be that bad, right? And I was at the very brink of like, okay, maybe we should stop offering this model because it's not good enough, and we can't really do anything about it. And the last thing I did about that was maybe I can run our internal benchmark and see how we can kind of like make a blog post on, we are probably removing DeepSeek from command code, and it's not good. It's not doing tool calls at all. We tried a bunch of different ways, and I was trying to prove that, it's just a bad model and it's not working, right? But then I've been building something. And that thing is called taste. You all know that. Like I've discussed that taste thing a lot. And if you want to go to our docs and take a look at our taste model, what that is, be my guest. Taste is a continuous learning layer, right? And I built it because I wanted my coding agent to learn from me. I have been writing code for 27 years. I've built so many things. If you go to my GitHub, you will see like I have like maybe 300 plus open source projects. 70 of them are probably really good, but everything else, I have like maybe more than 1100 repositories that are open source now, right? So I have a lot of thoughts and opinions about how software is made. And when I'm using coding agents, I want them to be learning my taste. They should be learning how I prefer things, right? So I built this taste model with my team, In the idea was that if you look at the scale divergence loop, if an LLM knows something, we do not consider that a learning. We think that LLM will just pick it up, right? If it does not, that is the thing that we learn, and we kind of put it in. If you're new here, let me actually open up. This is what taste file ends up looking like. It's very much like a skill, but it is automatically learned. So after like building maybe 30, 40 CLIs with comment code, these are all the things that it has picked up are my taste of building CLIs, right? And as the models have gotten smarter, this file has actually, gotten shorter, right? So a lot of things that models now already know are get automatically removed from here. So this is the taste file, right? And I built it for humans. I built it because I was like, the math was very simple, right? So here's a human developer, and they are gonna probably write a prompt, or maybe they are going to edit a file, or say no, this was bad, or say yes, this was a good tool call, right? And that is going to translate into software, right? So in this particular area, this thing, I felt like this is pretty important. Oops. I felt like this was pretty important. In this piece, when a human is talking to an AI through their prompts, through their edits, through their saying something like, no, this is really bad, or saying something like, I always prefer using Commander, I always prefer using TypeScript, something like that. Maybe we should be learning something from this area and storing that as a taste file, right? So this became the taste.md file, right? The problem, however, with this approach is, let me actually move it down a little bit. The problem, however, with this approach is very quickly this year we saw that in the same equation, humans are getting replaced by AI. Right? AI is actually going even a step ahead, a step up. Right? AI is being used to prompt. Like in the human part is actually somewhere here now. Right? Okay. So this is the current world we live in, where a human tells a coding agent that this is what I want, and the AI coding agent can spin up a bunch of different agents, do a bunch of different tool calls, do a bunch of different prompts, and do a bunch of different things, and write software, right? So I eventually ended up thinking that we can also learn the taste of an LLM, right? So this is an LLM. Since LLMs are writing more code than humans, we can probably learn the taste of LLMs, right? But it's not that useful. It's like I cannot learn the taste of DeepSeek V4 Pro or Flash and share that taste with you, right? What would that taste really be helpful for you, right? And how would I actually go and learn that, right? So I ended up building this weird experiment of sorts where I picked an LLM, and that LLM, as you know, was DeepSeek V4 Pro. I also tried this on Flash, by the way, and I set a goal. I'm gonna burn 1 billion tokens across different programming languages. I did TypeScript, I did JavaScript, a lot of HTML in CSS projects, a bunch of Go, bunch of Ruby, bunch of Python, and I think like probably 11 different languages that were done by Saqib, right? A bunch of different things, a bunch of different projects, and I ended up burning like 1 billion tokens. And out of this, I got this thing. I got the taste of DeepSeek V4 Pro. I should probably move it here. Pro and Flash. The programmer in me is typing double ampersand, as you can see, right? So I got a taste file. And this taste file is actually the taste of this LLM after 1 billion tokens on different projects. and I found so many amazing things in there. I found that I found a particular real particular things like when you're writing some particular Go routine, DeepSeek V4 trips up for some reason. If you're writing some interface with TypeScript, if you just ask for that interface, it will just do it really, really well. But at scale, if you're doing it a lot, if you're sending like thousands of different requests, if you're burning like a billion tokens, at scale, this open model starts to struggle. And the taste file started building up a layer of different fixes that when you are doing this, do that. When you are doing this, you always stumble on doing this poorly, do that, right? This was an interesting experiment, as you can imagine, right? Alongside this experiment, I started thinking about like how can I actually use this? What is the actual usage? Like if I have the taste of one LLM, where would I actually really need that, right? The second thing on the side that was happening was the errors, right? Uh, uh, the yay and the pros and the cons that people were sharing in the community, like, oh, DeepSeek is so good, in oh wow, everybody's saying that it's so good, but I think it's a hype, and people are just claiming things that are fake. I tried it, tool calls are failing, right? And then I think within a couple of days or whatnot, we had probably crossed like 10 billion tokens consumed on command code. So I had enough data for errors of tool calls, like for this DeepSeek model, that I was able to figure out a correlation between the taste that I had built in the tool call errors that were happening because of DeepSeek. And something became apparent. Like it was like, oh shoot, right? there are there's like a very clear pattern of things that this model is doing wrong. So I started with just 4 tool repairs. You know how there is a database migration, right? A database migration is like this. Maybe you are using Supabase or some, Postgres or something like this, right? So you generally have like this migration folder, right? And in this folder, you have probably, I don't know, some date file with some, I don't know, we change this table to fix username or whatnot. Um, and .sql, right? And then you have like a bunch of files like this, I don't know, table fix, authors or something, right? So this is how your migration folder generally looks like, right? So I started ended up building something very similar. I called it repairs, and I started looking at, this is the repair tool harness part of our command code, right? So I started building something similar, right? And it was like, I started taking a look at what are the most common things that I see across different models. So not just DeepSeek, but GLM, Quen, and a bunch of others. And I started to pick up on things. And these were the 4 most common tool call errors, right? So I'm just gonna probably bring them in here. Okay, that was a bad idea. Uh, Let me actually go from here, right? You can probably move it here and move this guy down here. Oh, that is messed up. I can. This is our repair harness for tool calls in command code. And this is what my repair folder generally kind of looks like, right? So when you are sending null for an optional field, a lot of these open models just omit it. Think of it like this. Think of it like you have like a shell tool. Think of it like a function, right? It's a shell function, and shell function can accept, I don't know, it can accept like A, P, C, D, like 4 arguments, right? One argument actually with 4 properties, right? And maybe the C and D arguments are actually optional. What I saw most consistently, the DeepSeek would send weird values across that. Like, so instead of sending an empty value, it will send null, and that will trip up our, come on. So what I saw was that DeepSeek V4 Flash would instead of sending an empty value, it would just send null, and our you know repair our Zod error schema was super strict. It would just reject it, right? And in other cases, it would be emitting something like this, which is not which is a JSON array of sorts as a string, when the tool schema was actually expecting an actual array, not a JSON string, right? And then in many cases, I saw that it started wrapping up arguments with a JavaScript object for no reason at all, right? As empty placeholder. So imagine you were expecting a value for D, but instead you got this weird thing, right? So it's not null. It's just an empty JavaScript object. So it will probably trip up this tool call a little bit. And whatever error handler you are using, or the type validator, what do you call it, library you are using, we use Zod, right? That Zod library would be like, oh no, you can't do this, you can't send this thing, this is against the schema we sent you, right? So this back and forth was happening, right? And it actually looked something like this. So think of this as command code, and this is your LLM, and this LLM right now is anything from DeepSeek, Quinn, GLM, Minimax. I think I didn't try on the Nemo models, but there was also Kimi, right? These were the models that I tried early on, right? So you're sending your LLM this data. You're saying, you can have a shell tool call, and it expects A, B, C, and D. And this A, B, and C and D could be like, I don't know, let's call it, what is your shell command? It is expecting a command, and you can also tell it when to shut down, like, the time when I think the idle time or something like this, right? That is quite common in shell tool calls. And the LLM in return is actually doing something very, very crazy, right? So this is, let me actually draw this. And yeah, there you go. So here's your prompt. Prompt is uh, this is your the developer saying something like, um, can you tell me something related to shell tool call, and the tool call is actually being transferred through your coding agent to the LLM. In the LLM, instead of returning back a tool call that has some data, like, I don't know, uh, run cat command or something, right? Uh, um, what is happening? Run cat command or something, and your tool harness, your coding agent is expecting some idle time here, like 9,000, like 9 seconds or something, right? And instead of this, it is sending this weird bug, right? Oh my god, making so many weird things today here. Yeah, instead, your LLM is returning something weird, which is not conformant of the schema of the tool call, right? So what happens here is, so this was your coding agent, right? So this was CMD, and this was your tool schema, right? And this is the tool call that we got from the LLM, right? And now that this tool call is a bad tool call, what's going to happen is Zod is going to take a look at it, and Zod is our type validator, and it's going to probably say, you can't do this. And it's going to probably return some giant big error object, which will probably be saying something like, I received this empty thing, and I was expecting either you will send me nothing, like I don't know, you will send me null, or you will send me a number value for this particular argument, right? In this error is now going back to an open model, right? So here's the problem, right? The open model will continue to send you back this thing, and it will do that for like 50 times, right? uh, that was the thing that I actually discovered. Like, it will, on average, it was failing like 56 times. Why is it not writing? Okay, enter 56. I think Exolidor has changed some shortcut or something, which is why I'm struggling a lot. But yeah, on average, it was failing 56 times. You would be getting the same bad tool call for 56 times, and Zod would be responding back with the error like, yeah, you can't do that, fix your input, and then I will run this tool, right? So I was like, I don't know, maybe I can figure out if there is a limited number of these bugs, and I can write a small repair harness on top of this, which would actually repair the tool call, uh, and fix it and run it, and then also send back a note, a fixed note to the LLM, right? Think of it like this. Think of it like, think, where is, think of it like you are teaching somebody how to drive a car, right? And you're sitting here, and the person who's learning how to drive a car is sitting here, and that person is about to hit a truck, right? You have two options. You can let them hit that truck and then teach a lesson of lifetime that, this is not how you should have done that. Or you can stop them, fix what they are doing wrong. Once you have saved them from that accident, you can explain that, you should have done this, your speed should have been this, and while you were like, 3 meters before this giant truck, you should have pressed your brake, because trucks happen to have pressure brakes and they can stop anytime, right? So there are two options. You can either tell them, well, this is your error, go fix, and by that time they are already dead, right? And probably you along with them. Or you can tell them, you can fix, repair what they are doing wrong. Once you have saved them from that accident, you can also then add a note like, this is what you should have done in the first place. So most of the harness right now in this space are doing just this. They get a bad tool call, they let it fail, and then they send back that error, but your session is already ruined. Your LLM, as a human, think of it like this. If you are interrupting a human from speaking 56 times in a row, when they are trying to help you build something, they will get pissed off. I always think of these LLMs like they have like a human, like because they're trained on our data, they act like humans, right? They will get pissed off. Their value to your task will decrease. Their intelligence, their cognition, cognitive ability, their capability will decrease, and they will, the overall quality of output will also get decreased, right? So instead of doing this back and forth, if you can fix and repair that bug deterministically and send back a note, I fixed this, here's the tool result, you should have actually done this, that can have amazing results. So I tried that, right? So in this scenario, what I did was, I was like, okay, let's break it down. I will probably try to fix all of this. Okay, this is taking too long. Okay, instead of Zod sending back that error, I redirected this thing. Okay. I redirected this thing to a repair harness. So we now have a repair harness, right? So as soon as Zod figures out, oh, that this tool call was bad and we have a bug, the repair harness actually has something like a migration, something of like a migration. It looks at this. Okay, I have this thing. and I know how to fix it, right? And what we do is we are like, okay, we can deterministically fix this, and a repair runs, and I call that repair, let's call this. I don't actually remember what I call it. Empty JS repair, JS object repair. What is happening with my typing today? Making a lot of typos for no reason at all, right? So we have a bunch of repairs, and this fix will go back to our repair harness, and repair harness will match this with, okay, we can actually fix this, and we will send this as an input, and we'll get back this output. Since we were expecting the idle time, and since there was a bug here, we can make a deterministic, call here, and we can say, okay, the idle time could be something like, I don't know, 3,000, right? Okay. And now this is what we have, and CMD will send back this as a tool result. But wait, just a minute, right? There's more interesting stuff that's going to happen here. So once you send this back, your whatever LLM you're using, open or close, it will now have a really good tool called result, and it will be able to continue doing what it was doing in the first place, right? A lot of people would have stopped right here, right? A lot of people would have thought like, um this is it, right? Because I am me, I thought maybe I can learn how well this does in production. So I made this repair, made it live, watched it 3 hours later, almost 6 hours later. And in the night, I was able to figure out that this is just still failing. It is able to repair like just 1% of the bad tool calls. And we have 96%, maybe 98% of the tool calls that are repairable, but we are not able to repair them. And that was happening because right after this uh, thing happens, let me actually make some more room for this. So right after this happens, the same thing, open models do the same bad thing. They are going to send back the same bad command, right? So the next tool call you get, you are again going to get something. I don't know, maybe you are running something echo or whatnot. You're again going to get that bad thing, that error that was wrong in the first place, right? This thing, right? And it would slow down. It would be just expensive. Sometimes it would do some weird thing that would cause it to just absolutely fail. And I thought of myself, what if, back to this example, what if I didn't just save this person from an accident, but also told them what they were doing wrong, right? Which is what we were trying to do here, right? Uh, I have a feeling that the way these open models are trained, they have this weird alpha male energy of sorts where they think whatever they are sending to you is right, right? Maybe they are being distilled from, distilled from big closed commercial models, and their training data set is something like, whatever this commercial model is saying is correct, so just learn what they are saying. So the open model ends up being whatever I'm doing is correct, right? So if you pass back a Zod error, the open model again says, no, you are wrong. I'm not going to listen to your error. This is just wrong. What I'm sending you back is the correct thing, right? So what happens is, if alongside this tool result, if you add such a small node, like this is a repair fix node on our end, right? I call it repair node, right? And that repair node is explaining exactly what Zod was saying alongside the correct result, right? So here's the correct result. This is what you should have done in the first place. But here's the repair node. You should actually, from now on, do this. this becomes the entire tool call that is sent to, I don't know, DeepSeek or some LLM. In the very next tool call they send, they stop making those mistakes all of a sudden. So this is such a minimal thing, and it has such a big impact. You can't believe it, right? It started with, you know, when an open model sends a bad tool call, you repair it deterministically without wasting any tokens, and you send back the correct result or near correct result by guessing what that model is doing. For example, if this was a read file tool, they would send no data of offset. Like, are you trying to read 100 lines from the bottom or the top of this file? So I would just say, okay, since I don't know, I would repair it and send them just the first 100 lines, right? But if that was a log file and the repair note was there, the LLM would quickly understand, oh, no, no, I actually wanted to see what are the last 5 or 10 lines of this particular log file, and would very quickly repair itself, right? And think of it like this, you just made a mistake because you were thinking about something and you were talking about something else, and you just ended up saying something, and without breaking your flow, somebody says, you mean this, and you're like, yeah, 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 and then you continue. That is what this is, right? The cognitive load that this particular open model is has, when you have like your 1,000 messages deep in 2,000 tool calls in there, a long session, a small tool call break can cause the model output quality to completely drop. And because you just repaired it, it stays the course. Now it can run 12-hour long, super, super long sessions. It can really, really help you, right? And this is obviously a model problem, and they can probably fix it in future models as well. But right now, no other tool repair harness is doing that, right? No other coding agent harness is doing that. So I thought this was really, really good. And I didn't want this to be like, oh, we only do this. I was like, this should be open. We should all have a really good experience with tool calls, especially with open models. So I wrote about it. The failure is not random. It is a small, finite, compositional, set. It's only these things that I discovered that day, right? And the tool repair, harness is just, they're like 30 to 100 lines of code that can deterministically run a small compute code, and it can just fix it in place. Your tool results go back to the model with a repair note, right? And it just becomes really, really nice. Um, Overall, this translated into a massive outcry. It's like a um, it's like a thing that people didn't expect, right? A lot of people tag DeepSeek. Oh, is it true? And a lot of people wrote like a bunch of different small harnesses. I saw like 10 different versions of this thing for Pi. I saw something for OpenCode. I saw something for what is it called, Hermes agent, right? A bunch of people, because this is out there and open, and the entire process is right there, and I'm not like gate blocking it. I'm not saying you can only have this in command code. A lot of people were able to discover a lot of shape invariants and fix them, right? And it just started this new thing, which is like, once you have these repairs in place, and once you have a coding agent like command code that can self repair, self learn, and continuously learn, what you have is a consistent, amazing feedback loop that is consistently figuring out errors and invariants in across different open models, in fixing them, right? In process, improving the speed, the flow, the quality of the output, and saving you a lot in token cost, right? So it started with just 4 tool calls, by the way. And the next thing I shipped was, I think, roughly it was something like this. It started with 4. The next ship was around 12 to 16, based on different LLMs. Like Quen have different quirks. DeepSeek is very different. GLM, for some reason, does not make a lot of mistakes. Kimi makes a lot less mistakes though. Kimi K2.6 stays my favorite, my top favorite open model so far, right? But once I fixed DeepSeek through these tool repairs. DeepSeek Flash is one of my favorite models. It is so good. It is better than Claude Haiku right now. Cheaper than like maybe 10, 20 times cheaper than that. And if you know what you're doing, you can just ask it to do it and it will just do it, right? As far as it is not breaking up on weird tool call errors, right? And now they're like I think 56,000 repair invariants we have. Like we have variations of 56,000 different small little tool call migrations based on the language, based on the model that you are using, based on the scenario, and we are continuously discovering more. And this number actually goes up and down. Like models tend to uh, become better at different times. Like for example, the same error that I just discussed here, most of the times DeepSeek does not have this error, which is so odd. Like maybe I have a feeling that when the capacity of inference goes down, when there are a lot of people using DeepSeek, it tends to become less intelligent. It tends to make a lot more mistakes, and that is when these tool call issues start to show up. So at a trillion scale, we are at a trillion scale right now. We have a trillion, more than a trillion tokens per month in command code. We see this so many times. We see this hundreds of thousands of times, right? So by building these small little repairs, we are saving you both cost, speed, and we are fixing these open models. It's such a massive thing, right? It's such a benign thing, and it helps in so many different ways, right? So this ended up becoming a thing, as you can imagine, right? A lot of people ended up talking about it. Here's Paul, who created the impeccable design scale, and he was like, this is super interesting as an idea. And then there were like a bunch of different other people, right? And a bunch of people started trying out. All of a sudden, a lot of people started saying, I don't know about this. Maybe this is not as much. And I ended up like doing this is when the tool repairs were like at 36K. I ended up actually creating a small info icon of sorts. Whenever you see this in command code, you would know that this thing, this whatever the thing, whatever tool call that was running with whatever open model was repaired three times with three different repair migrations before we sent back the result to the LLM. And you can see, okay, it's always like this was repaired once, it was repaired twice, it was repaired thrice. Obviously, as you can see, this is just a small smoke test where when the LLM was editing a file and we were expecting a file path, it sent us path. Right? When we were expecting old value, it sent us old underscore string as the argument. So we just deterministically replaced this with that and fixed the tool call, and also the new string, new value, right? So these are the three tool repairs that happened before this tool result, before this tool could actually run, right? If you were not using command code, or if you were using a coding agent that does not have repairs in it, right? It would just have potentially failed here, right? And then it would have failed here and here, right? So it's saving you a lot, right? And then a bunch of different people, starting talking about it. Like I saw something. Let me actually see uh, activity around it. We had a bunch of different people on Reddit. A lot of naysayers. They were like, I don't think this is true. But then I tried it, and then holy shit, DeepSeek works really well in command code. So it's not just the command code is not doing something crazy. This is what we are doing. We are building a phenomenal amount of harness engineering into command code. So it is actually a harness. It's not like, anybody can write 200 lines of code and call a bunch of tool calls and make a coding agent, but it's not like just a small little thing. It's a harness that actually helps you do what you are trying to do. It's not, it comes back battery packed, right? So everything is included in it, right? It's not, think of it like this. Like I think a lot of people like Pi, and I also think that it's a nice idea, but I feel like it mostly feels like Linux, where you install it, you are now responsible for all the drivers that you have to install, or you have to create your own drivers. And I feel like open code is more like Windows, which has everything. It has like 2000 plus models probably. They don't potentially, I think, care about what a particular model is doing right or wrong, because how can you do that if you have like 2000 different models, right? You have a very small set of models, the top open and closed models. And we want to give you people an experience like Apple, right? So anything that goes in my Apple iPhone is probably one of the best components there is. It's not like a random Android. And I say random Android with care because I know there are Android phones that are really, really good, but there are also random Android phones that you can buy for cheap or almost free. And they do not work that well. They have components that are way subpar, right? So we are building here at Command Code, we are building a coding agent harness that does not do subpar things, right? And I think one of the interesting things that I also saw was this guy. I think I'm not gonna butcher his name. I think he works at DeepSeek, right? And this is the part he really enjoyed that because, you know, the model was unable to recover because the error wasn't in form it could read. By the end, DeepSeek V4 Pro was able to beat, um, Opus 4.7. This was in our internal benchmark after all of these repairs applied, right? And it was able to beat Opus 4.7 based on the speed and cost. And it got to the same outcome that Opus 4.7 got to, like maybe 20 times with 20 times less cost and almost the same time, right? So yeah, this happened, right? And that led to a bunch of different things. One of the things that led to was, command code got adopted a lot. We are now second or third biggest coding agent usage wise on different leaderboards, like on Versal, which is one of our AI providers. They have an AI gateway. We also host GPUs ourselves. Um, and I ended up sharing a lot more around this thing. I ended up doing the same thing with Kimi. So if you are, down gonna wanna go down that road, you wanna see how Kimi K2.6 tool repairs work. You can, go read this as well, and a bunch of different other things, right? One last thing that I would like to share is this, like, now this is the landscape you live in. This is where the things are. So a lot of amazing open models are getting launched. So Qwen 3.7 Max, which was free for last 3 days on Command Code, um, Qwen 3.7 Plus, which probably is still free for like an hour or so. Then there's Minimax M3. There is there's Nemo from Xiaomi, and obviously there's DeepSeek. There's Kimi K2.6, which is my personal favorite right now at the time of recording this video, right? All these amazing open models are being launched. And the way people use these open models is pretty weird, right? Like, for example, if we go to Open Router, uh, let's go with ranking. I think let's go with apps. There you go. Cloud Code is on number fourth, right? We right now have, like, this is fastest growing this week. I think these are numbers per week. We are much bigger in numbers per week than this today, probably one day, right? So yeah, we basically are fighting for third and second spot. Hermes and OpenClaw have massive users. They are not coding agents. They are basically productivity agents, as you can imagine. But what is Claude Code doing here? Why is Claude Code being used for DeepSeek V4 Pro? Holy shit. Do you see that? Right? So a lot of people are actually using Claude Code as a harness for all these, open source models, right? I think this is a very, very bad idea, right? Let me tell you why. I think I made a post about it as well. Uh, yeah, there you go. Uh, uh, uh. I made a post about it. Like, stop using Claude Code for using open models. Um, this could very well be a separate video, by the way, right? Um, Let me share a little bit more. Hey, Himanshu, nice to see you here. Let me just take a quick sip and then we can get started on why I think using open models with Claude Code is such a bad idea. If you all have some comments, please feel free to share. Quickly moving things a little bit around to see what is up here and there. Okay, back to it. So a lot of people, as you saw on OpenRouter, this is Claude Code. Claude Code does not work with OpenRouter. This is a lot of people are actually probably hacking the API key and the base URL and changing that, and then running Claude Code as a coding agent harness for all these open models. This is a bad idea, right? Why is it a bad idea? Let's actually go ahead and talk a little bit about it. I'm gonna close all the unnecessary stuff here, so I have an easier time talking about this. Okay, this should be it. And I'm gonna start it like this, but maybe we will end up thinking of this as a separate video. So I'm gonna start it like that. Uh, if you are using Claude Code to use open models, open source AI models, you are doing it wrong. Claude Code is the worst possible harness you can use for open models. Claude Code is built for models only. Claude Code is built for Claude models by Anthropic. It is in their favor to not make it really, really performant for your open models workload, right? Your tool calls are probably failing behind the scene and you don't even know, right? Sorry, something is stuck in my throat. Okay, let's get started. So, a lot of times I hear this in the community that open source models are bad at coding. They're bad at tool calls, they are slow, and they do not work. And most of the times when I dig deep, I discovered that Claude Code is being used for open models. Claude Code is a great harness for Claude. Codes is a great harness for GPT. It's not really great, but it's like in Codex, GPT is super verbose. I don't like it personally, but a lot of people do, so I can respect that, right? But if you're using an open source model, and you're using Claude Code by changing its base API URL in the API key, you are actually in the bad, right? You're not going to have a good experience because most often this is what ends up happening. So let's say you start Claude Code and you change the base API URL in the API key with some of the open models, let's say DeepSeek, right? And then you're basically trying to use Claude Code with DeepSeek models, and this is what's happening behind the scene. So you send a prompt to DeepSeek. DeepSeek sends back a tool call. In that tool call, if it is broken, It breaks, it has errors in ways that Claude Code does not care about. Claude Code does not know about those errors because all the knowledge that Claude Code has is of the errors that they have seen for Haiku, Sonnet, and Opus, and Mythos, right? And if there are other errors, they generally just do not care. What they do is they send back that same error to your LLM provider. And if you have seen all of my work on the repair tool harness, you know that DeepSeek would continue to send back bad tool call schema. And this back and forth dance will continue for 50, 56 times in my experience on average before DeepSeek or any other open model will realize, oh, I've been sending this schema wrong, and I should probably send the right schema, right? And this entire back and forth loop will cause you to think that DeepSeek is slow, in the output because of this entire mess in your session, the quality of the output would have decreased a lot. So it's in your favor to actually use something like command code, right? Or there are other there are other harnesses as well that support open models really, really well, right? At command code, what we do is if we see that if you send a prompt to DeepSeek and DeepSeek sends a wrong tool call, we repair it right here. What is going on? We repair it right here before sending it back to DeepSeek, and that causes it to be more fast, and it continues to have a really, really nice, coding flow. So it doesn't break on just some weird, really simple tool call issues, right? And this eventually ends up being much, much more faster than Claude Code because Claude Code is consistently hiding a lot of errors behind that control O. You all might have noticed that I read 3 files. I tried to explore 4 different things, right, or whatnot, where they are not actually sharing what files were read, but they are sharing those only behind their control O, which used to be their main feed, and this is currently what it actually looks like, right? So this is so Claude Code used to have this feed where they would show you something along the lines of I read some file, I don't know, like index.ts, and then it would be like I edited something like package.json, right? This used to be the main feed, and when you would press Control O, you would see a lot more detail, right? A lot more detail around what was in this file and what was going around in this particular file. What Cloud Code has now done is they have hidden this feed behind Control E, or sometimes you can't even access this exact feed at all, right? So you have to press Control O and then press Control E to get to more detail. Probably, I could be wrong. Maybe that is not the case anymore. I haven't looked at it for like a month or so. And this thing, the which was the main feed, has become your control O feed. And your main feed, let's call it main feed. What is going on? Let's call it the main feed, right? And your main feed is actually now just saying uh, something like read 3 files, edited 1. It's hiding all the information that I think a developer would find really, really useful, right? So what's happening behind the scene is this works really good for them. It hides the main feed hides a bunch of different errors that you can probably see in the controller feed. But if you're using Claude Code with an open model like DeepSeek, you would not even know what is going on, right? So let's say you do a tool call. You send, okay, I'm gonna do a tool call. What is this? I'm gonna do a tool call. I'm gonna do a tool call, and the result that DeepSeek sends back has an error. That error is now sitting in Control E behind Control O, or not at all, right? And what you are seeing here is it is continuously trying to solve that error. Cloud Code continuously tries to repair itself or fix the tool call, and there's like a 56, 50 times, 30 times, depends on different tool calls and types and schemas, back and forth between DeepSeek and Cloud Code before DeepSeek actually realizes, oh, I've been sending this schema wrong, and it fixes it. And the outcome of this is a user like yourself would end up thinking like, oh, DeepSeek is slow, or open models cannot do tool calls really well. So more often than not, if you're feeling that open models are slow or their tool calls are not good enough, it is a harness problem, right? You are probably using the wrong coding agent for open models. So my request to you is you should probably try out more coding agent harnesses. It shouldn't. It doesn't need to be command code. We do a lot of repairs, but it can be any coding agent harness out there that is purpose built for open models. That is purpose built for the model that you are actually using a lot. It's fine to have experiments across the board. You can have like I think somebody was joking around and saying uh, every average developer has like 5 to 10 different subscriptions. It's fine to experiment, but once you nail down that, oh, I really like DeepSeek for Flash, you should also figure out what is the best coding agent harness for that. Or I really like MEK 2.6 and it works different across different coding agents, right? So yeah, you should probably take a look at that. And this is exactly what this entire post is about. Like I talk about, there are per model tool input repair that we do that Cloud Code doesn't care about, and then there's a caching issue that happens, which is another thing to care about. Like caching across different providers, even like the canonical model ID. Let's say Kimi K2.6 is like this with one provider, and it is like it has a different ID with a different provider. Doing that, dance of figuring out in keeping the cache correct across different providers per model when you have so many different models can be a headache, right? In Cloud Code does not honestly give a shit about this, right? They only do this for their own models. And if you're using Cloud Code for open models, you are wasting money, you're wasting time, and you are most probably getting a lower quality output from open models just because of your coding harness, right? And there are a bunch of different issues with compaction or whatnot that appear through all of this. I'm not probably gonna go ahead and read all of this in here, but I just wanted to point out that this happens, and any decent developer, if they just know that this is happening, can I think can figure it out for themselves. Oh, if an open model is taking too long, it is right now probably struggling. It is right now probably is it I if it is not down though, right? If it is working, it is live. It is probably struggling with tool calls. It is probably struggling with your coding agent, right? Yeah, that's pretty much it on Cloud Code idea. And yep, make sure you are using the right make sure you're using the right coding agent harness. This was such an interesting thing to figure out, and it has translated to so many different things for us. One of those things is actually what I'm going to talk about now, is the design slop thing, right? I'm going to stop the recording on my end so I can start again. Okay, done. If you all are watching, what are your comments right now? Feel free to share. Zed, is that still a problem? I see your comment on Twitch. Hey, Himanshu. Nice to see you here. Sricharan if I am not pronouncing your name wrong. Quick question: how does command code pull documentation context for the model? Does it rely on web search? And how reliable is that search in finding the exact context of the model needs to write code correctly without hallucinating? So for models, um, we do a lot. We cook in a lot of different things. Right now, what we are cooking is something uh, of a per model system prompt and prompts and tool call description optimizations. I think those are going to improve things a lot. But if your question is in regards of generally, if you are building something and you want command code to do a web search, it depends on the type of model you're using. I think we have web search enabled on Claude models and GPT models right now, but we are very close to shipping, a web search tool that works across the model as well. I think the PR for that is in. It should be probably shipped this week. There is also a bundle skill of Agent Browser, which is from Vercel Labs. Agent browsers like Playwright or something, and I use that a lot. It is one of the most fastest and token efficient way to browse the internet. It uses CDP. It uses your own Chrome profile, so it's hardly ever it's able to quickly find data on the web for free. So I added that in there. A bunch of people use it right now. Beyond that, reliability actually just honestly depends on how you are collecting context, right? I more often than not, because these open models are so dirt cheap, I have a way to I just go to, like if I have a very weird workflow where I just dump all of the code of all of the dependencies in the context and then ask it to fix it. So it's not relying on some outdated description in documentation. It's actually just reading entire context. Like, here is 600,000 lines of 800k tokens of context, and here is the bug I have. So now my coding, my session knows everything about all my dependencies and can easily use that source of truth to figure out the issue that I'm having right now. And because the per million cost of these models is so dirt cheap, like 100 times cheaper in some cases, it can try 100 different ways to solve that problem before it even costs me as much as Cloud Opus does, right? So yeah, it depends on what you're trying to do. Command has all these options available, right? Ketamine, nice to see you here. You're saying if I buy the pro plan, do you host models yourself or DeepSeek API? We do all of those things right now. Command Code has ZDR with almost every provider. ZDR models generally cost more. We also have a large international audience. Lots of customers who are in Asia, who are in Brazil, who are in Philippines. So we try to have like a global endpoint where we are serving the model from as close to you as possible. So a lot of our international users are served through model providers in Singapore. Again, if you do CMD underscore ZDR is equal to 1 and then CMD, you would be using ZDR models only. And if for some reason you find out that there's a model in our catalog that is not running through this method, you can just reach out and we can deploy one for you, right? We have done a bunch of deployments for different teams, which is the part which is a smaller portion of our revenue and smaller portion of our focus right now, but it I think will grow, where we are hosting models ourselves as well, mostly in the US and EU, right? So yeah, we have all the options. Reach out if you need a particular option, and we can figure that out for you and your team. But as an individual, you can by default you use the ZDR models. If there's a cheaper model and you are on a cheaper plan like Go plan, we try to route to the cheaper models versus the ZDR one instead of if you're not telling us to use the ZDR, if you're not using the CMD underscore ZDR is equal to one enforcer, right? if that helps. Okay, taking a look at a bunch of different comments now. Oh, I think Daily Mets Original on YouTube. I think I just answered the same question for ketamine. We host models ourselves. We use APIs from different providers. We have international providers as well. Depends on what plan you are part of. If you are on Go plan, you're probably getting served international models. If you are on Go plan and you're enforcing ZDR through CMD underscore ZDR, you will we make sure that you are getting a ZDR version of that model. It can be a little bit more expensive. If you're a team and you want a particular model deployed in a particular region like US or EU, we can do that as well. We have done that. We have like maybe 5-10% of our load going through our own GPUs right now. And that is only going to increase with more and more research we do in this area. Okay, this is the last video I'm gonna record. Probably next half an hour, and then we will, and that will be it. Oh, Bolts, I think I forgot to look at a bunch of your questions when you mentioned interface with TypeScript. That reminded me of LLM design slop. Oh, exactly. We are now starting a video on the design slop problem that we fixed. Let me actually bring up all the right links for this before we get started. So I think there is this one. There is this one. There is this. Yep. Oh, there's one more. I know they wrote a blog post. Okay. Where to begin? Oh my god. I'm gonna probably quickly eat something. I am parched right now. And then we can get started on this. If you all are watching and if you have some more questions that I can help answer, let me know right now. So Daily Myths Original is saying, by the way, I've noticed that DeepSeek often cannot escape the planning mode. It tries to create a .md file, then can't edit it, right? It's a very weird bug that happens a lot, and it's not a lot, but I've seen this happen, and I've almost always thought that it happens when you forget to do the shift tab thing, and when the session is running and you're not in auto mode, you are in the permission ask me permission mode, right? Um, and you realize that, but now you have like a bunch of different permission prompts, and you press enter through it very very quickly, and that ends up in entering you in a plan mode. In that plan mode, permission prompt doesn't actually end up showing. I think that's where that this bug is probably, but yeah, it's like trying to find the bypass or whatnot. I've been figuring this out. Haven't gotten to it. It's very easy to fix. Like any developer, when they see it, they can just shift tab out of it, so it fixes itself. But I am trying to not make a tool for this. Maybe there's a bug we can figure out. Otherwise, I'm going to have to make a tool for it so it can override its current mode and go from one mode to another. So it's an easier jump, right? Ritesh is saying Hi 3. Is that how we pronounce it? HY3 from Tencent is really good. Is this a model? Uh, I3 model. Okay. I have never used this. Okay, it's pretty cheap as well. How much is that? Is it new? I think if we go in rankings and look at the LLM leaderboard, okay, this is new. I think this is the model that was free for a while. I don't know how good this is. Most of the models are not coding models, so I tend to just steer away from them. But it does look like that it's one of the good ones. And are you in Discord, by the way? Can you like tag Sakib Amin there and ask him to like we should probably ship this, and you will see that it will be shipped in a day or so. If it can, pass. We have like this weird internal benchmark. If this model can pass that benchmark, we'll ship it in command code within a day, right? So just send us like a reminder there. Awesome. Okay, let's get started on the slash design slop thing that we have been building. How to get rid of design slop, right? Let me see where to get started from. This one is pretty close to my heart, so I think we are gonna have a lot of fun with it. Too big? I actually have a good example for this as well. Yeah, so this was actually built by the slash design skill we have, which is really nice. Okay, let's get started. Nothing new on Twitch. Okay. There was this post from Mario, I think. Oh, there you go. Here is the post. Oh, there you go. Right. This one. Right. Yep. Okay, let's get started. AI has a design slop problem, and we've all seen it, right? We've all seen those indigo gradients that a lot of people just randomly call purple gradients. They are not purple, they are indigo, by the way. And we have seen this weird, sidebar thingy that, side. I don't know what to call it. This side border with a border radius thingy that AI does. All these LLMs do. And Mario ended up, along with a lot of other people, ended up posting like, if we see this, we know that you are using LLMs. Like everybody's using LLMs in AI to make designs, right? So, sorry. So we wanted to fix this. Hey, hello, I am founder. So, hey, hello, I am Ahmad Awais, founder of Command Code, a coding agent with taste, which is right now one of the best possible harness for open models. And we have a plan that just starts with $1. That is how good of a coding agent plan we have. Oh, what is. I did not enjoy that. Let's do a retake here. So, hey, hello, I am Ahmed, founder of Command Code. It's a coding agent with taste, one of the best coding agents harness you can find on the market that is super optimized to work really, really well with the top models, both open source models and closed, right? And our plans just start with $1, so go plan, have 10x credits in it. One of the things I recently did, if you go to my X profile and go to the highlights tab, you will find that I was able to figure out a repair tool called Harness inside of this coding agent, where we built something that can, without costing you anything, repair your broken tool calls from most open models like DeepSeek. And the result and the outcome for that is something is fucking stuck in my throat. If you go to my X profile inside highlights and scroll down a little bit, you will see that a couple of days ago, or maybe like a month ago, I went viral when I built a repair tool called Harness. It's like a sort of like a deterministic set of repairs that you can do on open models. And I openly write about this. I openly wrote about this idea. It started with just 4 tool call repairs in command code, and now we have more than 50,000 tool repair variations. Where if your open model does something silly without costing you anything, we can deterministically fix that tool call and also send back a note that helps open models recover. Right? I have another video on this, and I have done I've written at lengths on this particular problem. But what I never saw coming was that we would be able to use this exact idea to fix the AI design slop. I'm really excited to share more about this idea right now in this particular meeting. Right now in this particular, and I'm really excited to share a lot more on this idea in this video. Right? You do a lot of meetings as a founder, and then this is what happens. Right? Okay, retake here. Sorry. So I'm really excited to share a little bit. So I'm really excited to take a deep dive into how we are fixing AI design slop with our slash design bundle skill in command code. So a couple of things you should probably know first. So slash design is a skill that comes bundled with command code. And it has a bunch of different guidance on how to build something like redesign, setup, or tokenize, how to review your design, like check up and figure out if there are design smells or typical AI sloppy design smell in there, and it can refine, like it can polish the voice of your content, improve the final finish, um, and it can style and do a bunch more things as well, right? This skill uh, has a really nice history of coming from the tool repair logic thing, and also it is being reviewed by so many different designers, right? So what happened was we were able to see. So what happened was we saw us. How should I put this? So when repairing tool calls, I saw a particular different pattern, a set of different patterns. When building the tool repair layer in command code, I discovered a set of predefined common patterns across different open models uh, that were deterministically fixable. And I ended up thinking maybe design has the same idea. Maybe this design slop we often see in different LLMs, has the failure of design data set is just surprisingly small. Maybe it's just, you know 14 different things that all of the LLMs do wrong, and if we can figure out and guide them and steer them into the right direction, they would become really, really good. We tried to experiment with that idea. It worked so well that we were able to bundle that idea into a skill for command code, right? It's not as deterministic as the tool call repair thing, but it is a bunch of different ideas that once your coding agent, your LLM knows about them, it can just start to figure out how to de-slop your design, right? So let's actually go ahead and go through all of this. So a typical model, when you ask it to build something, what it does is, sorry, let's actually go. I think this might be better now, right? Let's actually go through this together. So, how did we fix the AI design flaw problem in LLMs, especially DeepSeek, Kimi, Quinn, and also sometimes in Claude and GPT? I've been thinking a lot about why do all AI generated design look the same? Is it the same model problem, or the harness problem that you're using, the coding agent, right? And for context, we are fixing this design problem with slash design in command code. It has right now 16 different modes, 24 different reference documents, and almost about like 5,000 lines of code, which are encoded design tastes from some of the best designers I know. They've reviewed and improved them, and we are constantly shipping new things that different designers discover are wrong. So what it is able to do is this design scale. It reads your code base. It identifies what is broken. It can edit real files. It's not like Claude design of sorts. Not like a design system tool. It is actually a slash design capability, a skill for developers. Developers are mostly the people who do not know how to design well. So I'm really excited as somebody who's led a design led life, right? It's somebody who's really excited about design. I'm really excited to share a little bit more on this, right? This is not a Figma or a Markdown mockup thing or whatnot, right? So I've been saying it AI generated UIs for a while now, like everybody I know, right? And I've noticed something that I think is underappreciated. LLMs can write CSS fluently. I am of the opinion right now that LLMs can solve all the CSS problems that frameworks like or primitives like Tailwind actually fixed for us, the naming problems or whatnot. I think most LLMs are much better at writing CSS from scratch compared to using something like Tailwind. It's I know it's a hot take, and I always used to write CSS from scratch before everybody pressured me into using Tailwind. Tailwind is amazing. It has taught us a lot. It has also taught a lot of great ideas to the LLMs. But I consistently notice that LLMs are not bad at writing CSS files, but they essentially have zero design taste. And design taste is something that we care a lot about. At command code, a coding agent that is built around your taste, we are very much knee deep into learning how to do something really good, how to learn what is the best coding taste you have and make sure that it translates across your different sessions. We are now applying the same design same idea of taste. Sorry. We are now applying the same idea of learning taste, but instead of learning taste of design from just about everybody, we went after some of the big names in the industry, who are amazing designers, people I know, amazing good friends like Evil Rabbit from Vercel, head of design or whatnot. And we got them to help us improve what would be a really good universal design taste, right? And it landed up in something like this slash design scale, right? Um, LLMs can write CSS fluently but have essentially zero design taste. And the failure mode, where they fail on having a good design taste and do something random and sloppy, is not actually very random. It is a very specific, very small set of distribution, right? Let me explain. When you ask a model to build a landing page and it reaches into the mode of its training distribution, the mode of all landing pages across the internet is this. If there's a centered hero, there's some gradient text. This is the average, mode out there. A glass for a morphism card of sorts in three identical, feature tiles of sorts, right? And then there's the indigo accent and the interfont, a bounce animation, and this is what you probably would call an average website. And since by default LLMs write the average code they see across the internet, this is the average design that they see of a landing page, and that is what you get. If you ask it to design a landing page, you are getting this average design of a website. So LLM is doing exactly what we trained them to do. They are predicting the most likely next token given build me a landing page. And the most likely landing page is the average landing page. The average landing page is mediocre by definition. It has no design, right? I would probably say that an average, maybe median code that you can find across GitHub is pretty good, but the median design you can find across different landing pages is pretty bad, right? So that is what is going on here. This is not a capability problem. It's not that the models are not capable enough. It's like models know your models know what is OKLCH, the function that does really well on colors. It knows the prefer reduce motion thing, so it can build a really nice site which is more accessible. It knows the golden ratios. It knows how to set 65 650 pixel wide content. Like right now, this is not like super wide. There's like a 650 pixel wide thing going on here as well. Like let me actually check. There you go, like 566 pixel wide content here, right? There's a golden design ratio rule that a lot of designers do is they use 65ch to measure the main content, which looks really nice, right? In your LLMs, open or closed, they know about this. It just doesn't know when to use these things, because when is a taste problem and taste is not well represented across a statistical prior over the internet of the css we see on the internet, right? Think of it like this. So the job of an LLM is to predict next token, right? And it looks at the training data it has. And the training data has this landing page, which is here's a hero, which says something here, and here are three feature tiles. Uh, Probably should have done it a little bit better, but you get the idea, right? Okay, now it looks even worse. There you go. So this is, hello, something here. This is the average landing page that is in the training of any LLM, right? So when you ask it to design me a landing page, I need a landing page. Uh, LLM basically wants to predict the next thing, closest next thing possible, and this is what we all get, right? And I absolutely hate how bad this is, right? So it just doesn't know what to do. And if we can tell it what to do, it would do an amazing job, right? But a lot of people, like a lot of people, I used to think like, but how do you really go and fix the design, right? How can you just tell it, how can you tell it everything about what is wrong with the design, right? The thing is, as developers, we have been telling all these LLMs a lot about, oh, don't do this. I don't like, classes here. Just build a TypeScript interface and use pure functions. We have a lot of opinions when it comes to code, and we have almost none when it comes to design because we lack the understanding that an average designer has when they are designing an interface. So we thought, what if we gave this design taste to an LLM through a slash design skill? We talked to a bunch of different programmers and we were able to build a set of different things that LLMs almost always get wrong. And we almost always get this design slop. We packed that into a slash design thing and it works so well that I'm really excited to share. I am really excited to see what you all do with it, right? So let's start with the failure data set, right? The failure of design data set is actually surprisingly small, right? So the slop, whenever a slop is generated by LLM, we talk to a bunch of designers and with great design taste, and we ask them to label AI generated UIs. What are the tells? What are the things that help them, understand that? Oh, sorry, give me a minute. Okay, where was I? I completely forgot, lost the train of my thought. Okay, the failure design dataset is surprisingly small. We talked to a bunch of designers with great design taste and asked them to label AI generated UIs. What are the tells? What are the 10 most, turns out there are like 10, basically 10, what is? Oh, what are the tells? Turns out they are basically 10. And they account for 90% of the design slop we see, 90% of the signal of, oh, this looks AI generated, right? And those tells are roughly like this. So there's a tech gradient, there's a blue, violet, indigo, glossy energy on everything. There's a generic tech hue, which is indigo because software is generally mostly blue or purple. And it's not purple, by the way. I'm a big fan, huge fan of purple color. Author of Shades of Purple code theme here, as you can imagine. Like the first thing a lot of people find out about me is that I love the purple color, right? So I was like a little bit sad when I saw a lot of people saying, "Oh, there's a purple slop problem in design." It's not purple; it's mostly violet and indigo, right? And then there's a feature tile grid where there's an icon, a heading, a sentence multiplied by mostly three. Exactly what I drew here. This thing. All of which are equal weight and nothing is prioritized, right? And there is an accent tail. There's an accent rail. My throat is totally messed up today. And then there is an accent rail, a colored strip on a car design, a decoration pretending to be organization, something we saw on the Mario tweet, and a bunch of other people have shared this as well. And then there's an unearned blur, a lot of glass morphism because it was really cool maybe around 10 years ago. So there's a lot of it without any design depth built into it. Like a lot of people don't know. Like, look at this. Like a lot of people don't know. Like, look at this. This looks super flat, right? I have my image here, and Yeah, look at this. Look at this UI. I have my image here, and saying, in this particular box, it's just super flat. In while it does the job here, but if I go to my profile, you will see that this image here is right now crossing this particular element and kind of overlapping the element above. If I were to pull this down here, it would look so dumb and so without depth, you won't even believe, right? So depth, a depth system helps a lot actually when you're building some sort of really good design, right? In a lot of this is absolutely messing in sloppy design that AI creates. Then there is a monument of stat where oversized numbers are filling the space where product story belongs generally. And then there's an icon topper, a round square, icon above every heading as a template filler. I think this is the most common thing that, most common Tailwind template has. Like, I don't know, let's see if Tailwind still has that. Oh, that is tail css.com, right? So maybe plus, explore the templates. Maybe templates are much better now. Uh, 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 uh. Here's the feature section. Find feature. There you go, feature sections. Yeah, this thing, something like this, right? Round, big icon thing, and a bunch of text heading or whatnot. This is very common. We see this a lot in sloppy designs now. I'm not saying that Tailwind design is sloppy. I'm just saying that this is what AI has seen, and it just slaps it on everything without a thought on why it should be there or not. And then there's the center stack. Everything is centered because no composition decision was ever made, right? There's also the default type, which is Inter. Inter is probably the most used custom font across the web. I actually worked with Google on this particular data set when I was helping them write a chapter on Google Web Alumnoc on how different Jamstack frameworks in different web across the top 10 million websites look like, right? So I saw this firsthand, right? So all these, as you can see, are very typical tells that any decent designer can quickly discover. But if you're a developer and you don't know about a bunch of these things, you are in no luck, and that's why we are seeing a lot of design slop generated by AI being pushed live, right? So this is super similar to what we saw in LLM tool called failures, tool repair errors. There were just a few types, and fixing them made DeepSeek outperform 4.7. So I started researching maybe a dozen common patterns our design tells. Like there are like 10. The failure distribution is narrow. We could repair the AI design the same way we repaired the tool calls. Maybe we will not get to the complete 99% thing or whatnot. Maybe if we can improve the AI design by 90, 80, 90%, that is still a big win, right? That means it is a traceable deterministic problem, right? So we can do a slash design smell in command code, and it hunts down all of these, scores them against all of these, and then puts them on a out of 10 score or whatnot. Like for example, let me actually see if I can pull up a quick thing here. So I have a project called Words, and I'm gonna stash whatever is going on here. CMD slash design smell. Right now, this is using Quen 3.7 Max. We'll see how Quen does, right? So what's doing is it's figuring out all the design files, and right now it's referencing to the smell file that we have, uh, and then a report file. It's going to generate a report. It's reading all of the report files. And now it's going to look at that index.html file I have in this particular project. And it's going to look at the design and it's going to figure out, oh, these are the things that are wrong in your design. And let me actually show you what this website actually looks like, right? So this is the word counter site that I have. I often need something like when I'm writing, and I want to see how many words and characters are there. So I do words.awais.dev. It is absolutely generated by AI, and it's pretty sloppy, as you could imagine, right? But overall, it looked nice to me when I was shipping it. But let's see, okay, let's see. Okay, wait, give me a minute. Let's see what let's see what the slash design smell skill is going to bring up. And while this is happening, we can probably take a quick look at this. So slash design skill has help, checkup, and a bunch of different things that you can run. If you're not sure what to do, you can just go read the slash design help and it will guide you. But we have also cooked in a bunch of different ways where slash design skill can actually guide you what the next step is. So once it is done, Quen 3.7 max, which is taking a minute here, I will be able to show you what it comes up with. I have no idea what is going to happen. It is absolutely live, as you can imagine. There you go. So it says written markdown report, and it's also going to create an HTML1. We are still figuring out if you like one or the other. I actually tend to like both. So we just went with both for now, right? Let me see if I can open this up. And I'm going to preview this. So we got like 8 confirmed tells here. 8 out of 10, I think. And a bunch of different things that are wrong. There's a tech gradient. There is one generic tech hue. There's a lot of different advice around that. What is working, what is not working, and then guidance on what we should do next. We should probably run redesign layout, improve the voice, or improve the surface area of this design, right? Harden the empty states or whatnot, right? Let me also show you like what the HTML actually looks like. So it's done creating both, and it has done the smell audit of the design slop that I had. It's created 2 files. It's put them in locally in my project, and now it's saying okay, the design smell is complete, and now I can it's offering me a bunch of things that I should be able to do now next. But instead, I'm gonna just escape out of it, open the audit HTML. Okay, there you go. So this is the HTML report right now, right? On the design smells in this particular project. A bunch of different things. You can read through it. You can see why this score is being given to you, what is wrong with this score, what are the things that you can fix, and how. Like for example, there's a feature tile grid in about section. I don't even know about it. So in the about section, probably somewhere here. Yes, this is the about section and a bunch of different things, and it's asking me to fix it, which the slash design layout will do, and a bunch of different things, right? Uh, you get the idea, right? And it's also recommending what the next steps are, right? So yeah, coming back to the description here. Now that slash design can actually figure out on a scale of 10 what is wrong with your design. So the deeper problem is compositional, not cosmetic. The more interesting thing I found was that most of the tells are symptoms. They are not causes. The actual bug is not that the model chooses layout before. The actual bug is that the model chooses. The actual bug is that the model chooses layout before it chooses the purpose. A dashboard and a landing page have completely different jobs. A dashboard is a monitor surface, a status, alert, matrix, live data surface, right? A landing page is a decide surface, a proof, it has proof, it has risk reduction, it has one clear action or whatnot, like a CTA or whatnot. These need fundamental different spatial compositions when you're thinking as a designer. But the LLM reaches for the same centered hero plus a few cards layout for both, because that's the mode in their training distribution. That is the winning mode across the statistical average of the internet, right? So we built a work pattern first composition where before the agent touches any visual property, it must identify which of those seven patterns of surface it is serving. Is it a monitor surface? Is it operating? Is it operate, compare, configure, learn, decide, explore? Are we building search or filters or maps or galleries, something like this? Are we in? Is the user asking to build a settings interface, which would be something that requires configuration, right? Of a few forms, a preview, a commit area, or something, or maybe we are operating on something like it's a command bar. It's some form of inspector like in Figma or whatnot, right? All of this. Now, the model knows all of this. This is essentially a chain of thought for design, right? You basically, whenever you say, "Oh, can you please design this data so I can show it to my leadership?" This chain of thought with this information will help it figure out, oh, this is actually a monitor surface that the user is asking for, and we have specific guidance on how to build this in our skill, right? So it will force the model to reason about the purpose of the layout before generating the layout, right? I think there is a general lesson here. When an LLM is generating something compositional, code, UI, or writing, forcing it to commit to a structural frame before generating tokens within the frame, within that frame, it helps a lot. It's the chain, it's a typical chain of thought, right? It is the same reason chain of thought helps with math, right? Famously, LLMs were bad at math because they would hallucinate, and then we got them to think a little bit about all of what they were going to do, and then they were able to use tool calls or whatnot to figure out an answer correctly, right? You are reducing the entropy of the generation by conditioning on a high level plan, right? This single constraint eliminated more generic looking UI than any other aesthetic rule we wrote. Any other aesthetic rule we wrote, right? Many of the phenomenal skills exist in this space, and I bet they have a taste for great design. Like there's impeccable design, there's hallmark, there's a bunch of different things, right? But what they are not fixing is they are not fixing the chain of thought problem. We at Command Code are coming to this problem from a very different angle. We are coming from the angle of, oh, it turns out that design is a fixable problem, at least 90% of it, if we can see that most models are making the same mistakes again and again, or different model has a different design taste, which a lot of you already know, right? If we can help every model across this design taste, they are able to write great CSS. They are able to write phenomenal. They are able to create phenomenal things, right? So a lot of the skills that we see in this design space are somebody's great taste in design translated into words in a markdown. That is not what our design skill is, right? We are fixing it through a chain of thought, right? This this becomes really really good. I think that's why their skills are super loopy instead of being reliably good. So what happens is, I've tried a bunch of these skills. In on paper they are really good, and when I try for the first time or second time or third time, it's really good. But when I'm trying to get to that very last, like get me the purest form of the value here at the very end, it is unbelievable how loopy they are. They continue to do again and again the same weird thing that they did. They would burn hundreds of millions of tokens without actually improving much anything about my design, right? And that loopiness actually happens. My gut feeling is because they're not coming from this as a chain of thought problem. They are like, here's my design taste, help the user design well, right? The third one is validate, then repair, and then again, right? So my first version tried to audit and fix the design simultaneously. This is what many design skills do and fail. It's the pre-process approach, and it fails for the same reason it failed for the tool calling. You were encoding you for the tool calling where you were just, here's the tool call, and you send back, here's the error, right? And the model does not listen. It does not care about your error. It knows that you are doing something wrong. The KL divergence, the entire weight of the model thinking that it is doing something right compared to you, the entire prior it has is bigger than what your prompt. So it just does send the same bad thing again. So that is what also happens with design. If you say the right thing, it would still do the wrong thing, even if you tell it the what the errors are. Right. So you're encoding a prior about what's broken. You get a false positive that is silently corrupting things. It would recolor something. Like for example, if you say, I don't like the colors, can you improve them? It would recolor something that needed relayout. It would polish typography on composition surface, right? And that was this. It is just fundamentally wrong, right? The thing that worked really well is when we separated the diagnostic from the treatments. We are in our slash design scale. We diagnose what the problem is, and then we figure out what the treatment could be, and we can then run a bunch of different small agents to help you improve your design, right? And make that a mandatory pair. So every diagnostic would have a pair of treatment alongside it. That is what our audit modes do. So we have slash design checkup, smell, and review. I already showed you what the smell looks like. Slash design smell thing looks like. And produce structured reports. These are treatments. These are diagnostics that are really helpful for treatment modes. So the treatment modes are redesign, relayout, recolor, typeset, motion, interaction, responsive, and a bunch of others. These treatment modes then consume these reports before making the changes. They understand what the diagnosis is, what the problem is. They figure out through the chain of thought what the problem space is. The audit is localizes the problem, and then the treatment mode only spends repair budget where the audit actually disagree. So it figures out, oh, this is the problem. This is the small thing that I need to fix. I don't need to go if I for example, if you say go change improve the color, it will go ahead and change some random color across your design. It's not something that a good designer would do. A good designer would have taste. A good designer would figure out, oh, I don't like how saturated this gray color is, and how this particular link has no color. Maybe I should add a blue saturated blue color here, which looks more which looks better, right? So that is what this entire thing is trying to do. The slash design, scale in command code. Same shape as tool call repair, by the way. Let the design system complain first, then we fix only what is complained about. The validator does the localization work for you. It is cheap, and then it is careful. It is a fast path, and then there is an evidence. I keep seeing this pattern everywhere, right? I am actually building something really cool that I'm really excited to share very, very soon. This pattern applies there so well. You're gonna have a lot of fun with all the launches we are going to share in June, right? Okay, moving on. Treatment modes don't just do report cleanups, they run their own full pass after absorbing the report. The report is more context, it is not a to do list. It's just context, right? It's not like, do all of these things. And another thing I discovered, I personally have known about OKLCH color function for quite a while, but I never really use it. It is too complex for my taste, right? But I found out that that OKLCH, and I found out through two amazing designers I have on my team. They wrote a blog post about it, Namer and Ubad, right? Uh, I found out that personally I always struggled a bit with OKLCH CSS function, right? But it matters a lot for LLMs. And this one is fun. LLMs default to HSL, because that's what is in their training data. HSL is a lot is used a lot more than OKLCH, right? So HSL mode of lightning when you're creating colors like this one is perceptually non-linear, right? So this is any say HSL color. I'm actually a little bit struggling to share what this is. Maybe I can go to VS Code where it would automatically get highlighted, so you can see. Yeah, there you go. Right. So uh, HSL lightness is perceptually non-linear, right? So look at this yellow color and look at this blue color. They have the same lightness score, 50% here, 50% here, but they look absolutely different to a human eye, as you can see right now. And because of this extension that I have, which is automatically trying to fix this, you can see, it's very, very hard to read the text that is black on this particular blue color. But if I, hover over it, you can see it's very easy to read the white text on top of this blue color. Um, but on the yellow color, this particular yellow color, that is not a problem, right? So things like this are absolutely, LLMs are completely blind to things like this, but humans are not, right? So when the model tries to build a consistent palette, keeping the lightness, the L constant of the result, it looks wrong in ways that model cannot even diagnose with CSS alone, right? So OKLCH, however, has perceptually uniform lightness, right? This means a model can reason about color mathematically, right? And have a much better result, right? It actually matches the perception the model has picked up that you are trying to build. So equal steps in numbers and spaces produce equal steps in visual space. It's the right abstraction for LLMs to work in because it makes them optimize the landscapes. It makes them optimize your entire design in a much more smooth and coherent way because they can now control the color mathematically and be sure that even to human eye it will look really really good, right? Whereas HSL doesn't really work. I think this generalizes, right? When you are designing an interface for an LLM to work through, whether it's color space, a schema, or an API, choose the representation where the distance in parameter space correlates with the distance in the output space. Your LLM should have a really nice feedback loop. The model optimizes over parameters. The mapping from parameters to output is non-linear, right? And like all the model is trying to do is it's non-linear, full of discontinuities, as we saw, right? The model is struggling. It's trying to figure out what you're trying to do, and if you and it's also like making a mistake. It's hallucinating with predicting the most used common method to do something, which will cause it to not have a good feedback loop. So so the model will struggle even if it knows what is the right move here, right? So that is the entire thing. The model knows what is the right thing to do, but because of the statistical average of HSL, it just chooses to use HSL and then it struggles because it cannot mathematically fix the color. And we can go even further. The agent picks emotion before hue, right? Calm versus urgency versus trust versus momentum. And then it builds the palette in OKLCH with constraints. You can clamp the chroma at lightness extremes. It can tint neutrals towards brand hue. It can do a bunch of different things with these emotions, right? Instead of picking color hues, it can figure out like, okay, this is the emotion of this template. This is a site for cooking. This is a site for developer, right? And you can figure out and play around with the colors if it knows what it is doing, right? The agent can't default to Indigo now, right? Because now it has this system, and that system requires it to reason before picking up a hue, before picking up a color. No more Indigo slope. It's Indigo, by the way, it's not purple, as I said before, right? And then the fifth one, the state coverage is the most honest metric, the most quantitative signal we found. Count the number of interaction states per component. So interaction states are like this. For example, if I hover over here, something happens. If I hover over here, If I hover over on this thing, even this just this light, this component has a bunch of hover states. If you take a look at this, I don't know why React Native is trending right now, by the way, right? So the color changes in the background, and then the color changes here. And when I pick this up, a bunch of things, all of these are states in design, right? So when a human designer ships something like on average 7 to 9 states, so everything has an idle state, a hover, active, focus, loading, empty, an error state, a disabled state, an overflow state. But when an AI agent ships, it only picks like one or two, states like idle and maybe hover, because AI by default is super lazy, right? And that laziness causes it to do a lot of slop. So this is clean in a measurable proxy for design quality that requires zero subjective judgment, right? So we built, guardrails for this. If we can just count, does this button have focus state? Does this form handles an empty state? Does this handle? Does this list handle overflow? The median of AI generated component is like 1.5 states, right? And the median of human generated components, human designed components, is like 6 plus. So roughly an order of magnitude. The gap is enormous and easily you can easily trivially detect it, right? So that is what the slash design skill does. It detects the number of states AI has created, where AI has become sloppy and lazy. It is right there in in the plain sight, right? All the amazing things that are slash design skill, all the amazing things it does, all the amazing things you can do to fix this, design slop, right? And you don't even have to know about all of this, which is why the slash design skill exists, right? Or you can go knee deep into this. This is why I wrote this engineering deep dive, because I was so excited about, like, okay, wow, I didn't expect this outcome from a bunch of weeks of research here, right? And sixth one is a meta observation here, right? It beats an infinite loop. The biggest failure mode of AI design tools I found is that you detect a problem, you attempt a fix, the fix creates a new problem, you attempt a fix, and it continuously loops back, right? This is the problem I was talking about a little bit before. In different design skills, they have a lot of amazing people. They have amazing, great design taste. They encode that design taste as a skill, but they are not thinking very logically of how an LLM is going to think about it, right? And then they become their skills become extremely loopy, right? The agent re-enters the same mode, hopping from one different result to another, and it never really converges to a point of figuring out how to solve that problem. So we solve this with a reward model in plain English, right? After each mode completes, the system recommends 2 to 3 specific modes. So redesign gets a bunch of things, like it can validate a change, smell, finish, and refine. It can when you're done redesigning, you do a slash design checkup and review, and you can validate if that change is really good. If you are done with the slash design smell, you can run finish and refine, because it will fix what was found in that design smell report. When you've run slash design recolor, it can do a bunch of different things. It can test different viewports and add transitions or whatnot. I know it might not be very obvious, but these things become really, really, really helpful when you are quickly designing a system across a lot of different agents, right? And finally, finish. When you run a finish, you can then run typeset and recolor, which will fine tune the last few details on what your type should look like. And maybe we should recolor small little things, like all of this thing is, as you can see, it has different colors. So one is white, one is this saturated gray, which is, I feel like, a little bit different than this one. And then there is blue, right? All of this recoloring it can do, the fine tune, the last part of the polish, right? So the with this, the flow becomes, you build it, you audit it, then you refine that audit, and then you style it, and then you create the front end related stuff with it, and then you finally ship it. The agent just knows what to do next. It's instead of rerunning what it just did, it knows where in this particular loop it is. This is a trivial intervention, but it basically ends up looking like a lookup table, right? It eliminates the looping problem a lot. it's not entirely gone. Like with some really cheap open models, I see the loopy problem come back even with all of our fixes. But yeah, you're using a cheap LLM, so what do you care, right? You can run it. You can run the refinement part with a much better model, right? But it does eliminate the looping problem almost entirely, which is super common in most design skills out there. And I think seventh is truthful completion is the hardest constraint, the most insidious AI design behavior, claiming the work that isn't visible. I added hover states when there are no hover CSS, no hover CSS were written. I've improved the spacing. We've seen this a lot where you say, where you talk to your LLM, can you improve the spacing? And it will come back and yeah, done. And it would have just just fix a small margin somewhere and enhance the motion or the animation, the motion when no keyframes even exist in your design. So every mode has a bar, the minimum visible change required for the mode to count as complete, right? So when you run slash design typeset, must the typeset must change the body text and headings and the scale of the text, how it shows in the labels, in the button text, in the form text, in the metadata, in the responsive behavior, because now the text is different. Changing only the hero headline is not enough, right? Similarly, when you run slash design motion, it must add some animation to at least 8 transition moments, right? Changing one easing value is not enough. It would just look very weird, like the bouncing animation we see quite commonly, right? We should instead see a staggered motion of different components, right? The agents can't claim motion is improved because it just changed the duration of from 200 milliseconds to 250 milliseconds. The user must be able to see new and clearly better behavior. This is surprisingly hard to enforce, by the way, and the single most important quality constraint in our design system. We still haven't gotten this right, and there's so much we can improve. This is basically a design constraint. We have done what we can do as our team and our designers, and we are looking a lot, outwards, seeking a lot of help from different designers who can come help and improve the, uh, you know, motion design part of all of this, right? Finally, here's a meta observation about design skill in general. Uh, what we built is basically a reward model for design, implemented as structured English instead of a neural network. It's English because it's changing so much. It's not We are not trying to find a model and call it David like, oh, this is the best model that can design the best things, right? That is why it is just a way of structured English. It's a hardness engineering of sorts that is repairing the design slop problem. It defines what good looks like across 24 different reference documents. It gives in LLM a rubric of sorts. It lets it self evaluate, and then the 10 design smells with another negative reward system, lots of state that make your design go through a completeness check, and 7 patterns in a surface, structure surface prior. All of this becomes like a design prior of sorts. Like it becomes a taste, good design taste that any LLM can use to improve your design. And I'm sure this is going to grow, right? This is taste engineering in a limit of sorts. You're not writing instructions, you're writing a curriculum of sorts. The model already has the capability to follow that curriculum. It can write any CSS. What it lacks is the policy. What do you think is the right thing to do, right? On when to use this, when to use the capability it has, and what the good looks like, right? I find it interesting because the policy is so compact, right? So it's just 4,500 lines of design taste. Right? Whenever I saw like the design slop, I was like, oh shit, so much needs to be improved in that. And I was like, sort of like shocked when I saw that only just like 5,000 lines of code, not really code, but mostly English, in just like 24 reference documents, 10 design smells, 7 different surfaces. Just this small little surface can improve design so much. It's like the design taste is well enough that the output passes a designer review. Like we created a bunch of different designs, um, and showed it to a bunch of designers, and they were like, they were not able to pick up that if this is generated by AI or human or not, right? Like a human designer worked on it or not, right? This suggests that taste, at least for UI design, is lower dimensional than it feels. It's not an infinite space like we think, right? It is more subjective preferences. It's a finite set of principles, and when applied consistently with some logic, with some chain of thought, with a small catalog of common violations, it becomes really good. And the model didn't change here, by the way, right? We just told it what the good taste looks like, how to logically think about it. In the same lesson, again, same lesson with tool calling, it's not a capability gap. Model already knew what it was doing. It's again a contract gap. It's the hardness. It's the way you are using that model is wrong. The model knows how to write CSS. It just hasn't been told what the good CSS would look like in this particular surface that you are in right now, right? I now believe that different LLMs have different baseline design capabilities, but it's your coding agent, the harness, that makes the difference at the end, right? In the end, the model didn't get better at design. The harness design, the harness actually teaches this. In this particular case, the harness is the slash design skill. By the way, it is teaching what the designers, human designers, would look for, right? And I'm sharing this all in public, so anybody can improve this, right? You can go ahead and try it out today. You can just install command code, just like I did, run the design smell, and try to improve your existing design and see how much more you can do with the slash design skill, right? The next couple of things that I will probably share is yeah, there's a page on this in our docs if you want to read a little bit more about it. And there is a blog post which goes through all of these things. You can quickly see this is like a design partner for developers, right? It's like a design co-pilot, not for designers. Every design AI thing that I see in the market is for designers, right? Designers are already really good at design, right? Us developers are stuck with bad design taste, right? So it's a really nice tool that can help developers design like a designer, right? And when in doubt, as I mentioned before, come again, where is it? You can just go through slash design help, and it will show you what you can do next, what you should focus on or what not, right? Yeah, I hope that helps. And the very last thing that I'll share is this is the design skill from command code. This is the applied form of it. I had these deals listed. They had so much text, and the designer in me was like, oh, I gotta do more. I gotta make this much better than it is right now. So it was really on, or like this giant piece of text, like this giant piece of blob of text, right? So I gave it this something like this with the slash design skill, and it ended up doing this, which looks really good to me, by the way, right? It was able to figure out what we are doing. The emotion behind this is it's a deal. So it created a ticket like thing, the ticket that we actually see when we go to a cinema or something. It basically did a folding thing here by default. So this is what it looked like by default. So this is like a ticket of sorts, like a deal for DeepSeek. And the most important thing was it is 4x cheaper or 99% cheaper, and this was it. But the details were hidden. But the engineer and me got out. I'm like, yeah, people are asking so many questions. We should not hide the details. We should just, ship them all. And but right off the bat, this looked really really good, and it is responsive. Like for example, let me go and show you how. Right. So there you go. As you can see, a lot of things that are changing. I did not tell it about any of those things, right? It's purely an LLM. I think it was Kimi K2.5 or maybe DeepSeek V4 Flash, one of those two, in the slash design skill, where I pointed out that can you go to the deal section and fix the design there, improve it, and this is what we got, right? So I'm pretty excited about this. I think this is amazing. I think we are going to discover a lot many things at Command Code that we are going to improve across the board throughout all of these things. It's going to be crazy, crazy awesome. We're cooking something really, really cool up next. So if you're around, if you want to give it a go ahead, download Command Code, and try out the slash design scale. It's not where we want it to be. It's improving on a daily basis, right? We are about to ship something called slash design slop. So it would just automatically figure out which of those reference documents to run to figure out what the total amount of slop that exists in your entire design, and then it can guide you through, now you should run this and that, right? I think that would be really fun. It's coming probably end of this week, right? And that's pretty much it. Man, I've been live streaming straight for 4 hours now, maybe more. uh, Let me stop the recording right here. And if you are still watching me, let me know what your comments are. I'll take a few comments and then I'll just, go uh, rest up and start building something cool today. Okay, I see a bunch of comments on X. Can you add support for Teamex? Don't know what. Okay, we will, Ritesh, we will take a look at what CMX is doing. Um, CMix is pretty new. Can you file this through CMD feedback? If you could just run, CMD feedback, you will be able to file this as a feature request on our GitHub repo. That and add all the context. Like I've been asking everybody, like add all the context, all the links, like link to CMX or what OS you are on, things like that, and then we can just feed that back to command code to fix itself. It tends to do that, right? The more, the easier you do it for us to reproduce a problem that you have. So the easier it is for us to fix it very, very quickly. And there are a couple other comments, I guess. I think Sricharan is asking about partnership proposal. Bro, you can reach out, support at commandcode.ai, and we'll figure something out. Ritesh is saying $15 is good for Mimo DeepSeek the last month, but do not mix Kimi in it. Kimi is really good. Uh, it can be sometimes expensive. Kimi K2.6 is basically as good as Opus 4.6 for me, right? So think of it like, you're still paying like 10 times less. From looking at YouTube comments now, I think I've addressed that. DeepSeek V4 Pro is really doing the God's work here. Working on an internal event planning tool for my company right now, and I didn't expect it to perform that good. Didn't have to pull the codex. Yeah, there you go. DeepSeek is pretty good, right? $5, 180 million tokens, bro. You are doing it. This is how it is supposed to be done, right? A bunch of comments on Facebook. Does design work for front end apps as well? Yes, it does. I have seen somebody. It is a it is meant for front end apps, by the way. I don't know what you mean, Nightfolk. I have actually seen somebody use the design skill to build an Android app. I didn't know that the design skill would be good for Android app. That's why it's not deterministic. It's not like we didn't advise it to write CSS code. That is why it is structured English, because design exists in so many different ways. And on Android, I don't know how you do designs. I'm sure you're not doing CSS. You have your own way, but the same skill, kind of, because it's English and the LLM knows how to do Android apps really well. It can just apply that knowledge, right? Okay, I'm pretty much done here. For more questions, please hang out in our Discord. I'll be there. All of our team is there. And go ahead. Feel free to follow me on Twitter and YouTube. Um, I will be posting. Zad will be helping me out to post all of these videos. We've been posting them like I do live streams every week. Not been doing that in May, but I'm now getting back at it. So hopefully we can build a really good community together. I'm hoping we can also do a bug bash of sorts next week. We'll see how it goes, right? Ritesh, can you make the pro plan 25 or 20 so that it lasts a month? We are figuring something out on that, by the way. Like we are figuring out how can we split up something that would be really. I'm trying to not share a lot of details of it because none of it is final. We're trying to figure something out. Um, it's like we are trying to figure out if we can do another new plan, which is a $10 plan and a $20 plan, and maybe something in the middle, which is like a $60 plan, which has a lot of usage. Being a young company, we have to be very, very careful because GPUs are very hard to find, and we are still kind of bottlenecked by all of the capacity we have, right? And we are still figuring out the limits with a bunch of our upstream providers. And the Go $1 plan, which is giving you 40 to $50 of usage, which is the best plan in the industry right now. Somebody actually tweeted that this is the best coding agent plan in the solar system, right? At that level, per user rate limits, we are able to figure out. Even when we go to 20, that is like probably, I don't know, 10x more. In that part, we are still working on. Hopefully, in June, you will hear back from us and we'll be able to, launch a really nice plan that would work for anybody, right? I hear you on this, right? Just know that we are working on something really, really cool. But at the same time, there's a lot of bugs and a lot of features we have to, launch. And we are hiring. That's why we are hiring, right? So much work to do. Scaling really, really well, though, right? So, super appreciate you all hanging out on the live stream today. Uh, and see you next week. Bye. Ciao. Peace. Use your